What's up everybody, Rafael here and welcome to the channel Network Engineer Pro. In this video, I'll be covering OSPF passive interface. OSPF passive interface is something that you should know as a CCNA. You're also going to see it on exam blueprints for CCNP level and above. OSPF passive interface is also a very commonly used feature in production networks. It's not one of those super rare features that you only need to know to pass an exam that no one ever uses. No, 99% of enterprises out there that run OSPF use this feature where it makes sense to do so. When you are adding interfaces to OSPF, whether that's the global OSPF process using the network statement or directly at the interface level, something happens. OSPF hello packets are going to be sent outbound from those interfaces to find a neighbor, right? They want to find a friend, build an adjacency, and start sharing routing information. Let's hit the whiteboard really quick. All right, so here's router 1 and router 2. They are directly connected on their gig 0/0 interfaces, and they both share a common subnet. I can get router 1's gig 0/0 interface to participate in OSPF one of two ways. From router 1's global configuration mode, I can say router OSPF 1, which defines the process globally on router 1, and then add a network statement that falls under router 1's gig 0/0 interface. So one option would be network 192.168.1.0 with a wildcard mask of 0.0.0.255 area 0. So I'm telling router 1 that any interface that falls under 192.168.1.0/24 participate in OSPF, specifically in area 0. I can also go under router 1's gigabit 0/0 interface configuration mode and say IP OSPF 1 area 0. Both options accomplish the same thing of getting router 1's gig 0/0 interface to participate in OSPF. Now, as soon as this happens, router 1 is going to start sending OSPF hello messages with the purpose of discovering a neighbor, building an adjacency, and sharing routing information. Now, if I do the same exact thing as far as the configuration here on router 2 will also start to send OSPF hello messages with the same purpose. Router 1 and router 2 will eventually see each other's hello messages, and as long as certain things match inside of the hello message itself, they will successfully become neighbors. They will be best buds, and they're going to share routing information. Cool. Most of the time, that's fine if you're expecting an OSPF adjacency to form between two or more routers, but some cases you're not. Let me show you what I mean. All right, so I added some devices to the topology. I added a switch here and 3 PCs. This could be an entire building or maybe a floor of a particular building. There's a new network for this floor or building. It's 192.168.2.0/24. Now, this network needs to be known throughout the entire OSPF domain. And as you recall, that can be accomplished by the network statement under the OSPF process of router 2 or directly at the interface level of gig 0/1 on router 2. Now, remember that once you do that, OSPF hello messages will start to be sent in that direction to try and discover an OSPF neighbor, right? More friends to become neighbors with and share routing information. Now, the question that we need to ask ourselves is, am I expecting an OSPF neighbor here on this side, like from switch 1? No, I'm not. So I shouldn't be sending hellos then. Why waste processing power sending hellos every 10 seconds, for example, if no one's going to listen? There's also some security concerns with that, right? Like, I don't want a hacker, let's say PC3 is some sort of malicious hacker, I don't want a hacker to receive OSPF hellos and then run some sort of hacking software that runs OSPF, become neighbors, and start sending bogus routes into the network, causing all kinds of havoc. So what's my option? I can't remove this network here from OSPF because, again, the entire OSPF domain needs to be able to reach it. So my goal is to keep this network here in OSPF, but not send hellos in that direction for the reasons I mentioned a few seconds ago. That's exactly where OSPF passive interface comes into play. I can tell router 2 under its OSPF process, router OSPF 1, passive interface, gig 0/1 1. Once that happens, gig 0/1 will no longer send OSPF hello messages, but this network here, the 192.168.2.0/24, will still be known within the entire OSPF domain. All right, so now that we understand the theory of what passive interface is inside of OSPF, let's head to the lab and get it configured. Alrighty, so here's the lab. It's the same concept from earlier in the video. We have our two routers here, router 1 and router 2. And over here on the other side of router 2, we have a switch with 3 PCs. And you can see here our objective is to configure OSPF and prevent router 2 from sending OSPF hellos out of gig 0/1. Now, the only thing configured on this lab so far are just the IP addresses on router 1 and router 2. We need to configure OSPF from scratch, so let's go ahead and do that. So on router 1, I'm going to go to config T. I'm going to say router OSPF 1, and I'm going to add a network statement that matches gig 00 on router 1. So I'm going to say network 192.168.1.0 with a wildcard mask of 0.0.0.255 in area 0. Now there are some other network statement options I could have used, but let's just keep it simple. What I'm saying is I'm defining router OSPF process 1, and I'm telling router 1 that any interfaces that have an IP address with 192.168.1.0/24 participate in OSPF in area 0. Now I could have also configured gig 00 to be an OSPF directly at the interface level, so I'll go ahead and do that on router 2 to show you what that looks like. Config T, interface gig 0/0, IP OSPF 1 area 0. Both of these options accomplish the same exact thing, getting gig 00 on each router into OSPF. Now, after a few seconds, we should see a syslog message pop up that both of these routers are neighbors and they're in the full state. So let's give that a few seconds. All right, perfect. This is the message I want to see. We can see that the OSPF process number 1, we have a neighbor 192.168.1.1 on gig 0/0, and we are full. So that means router 1 and router 2 are OSPF neighbors. I could also verify this OSPF neighbor information by saying show IP OSPF neighbors. And I can see here that router 2 has a neighbor 192.168.1.1 in the full state off of gigabit 0/0. The next thing we need to do is we need to get router 2's gig 0/1 interface in OSPF, and that's that network up here, 192.168.2.0/24. So I'm going to go to config T, and I'm going to go directly at the interface, and I'm going to say interface gig 0, oops, not that interface, sorry, interface gig 0/1, IP OSPF 1 area 0. Now router 2's gig 0/1 is connected to a switch. I'm not expecting an OSPF adjacency to form here. But before we continue, I want to make sure that router 1 knows about this new network 192.168.2.0. To do that, I can say show IP route. Here I can see an OSPF route for 192.168.2.0/24. That's perfect. The next thing what I want to do is I want to debug the IP OSPF hellos. So to do that, I say debug IP OSPF hello. Now, after a few seconds, once hellos start being sent and received, we're going to see some messages for that. All right, now a few messages have popped up. Let me go ahead and stop my debugs by saying you all, which stands for undebug all. Now, right away, we can see that we received a hello, we sent a hello from gig 0/0. That's going to be in this direction from router 2's perspective. Router 2 is sending out hellos, and it is receiving hellos inbound on its gig 00 interface. Something else we can see here in this debug output is that we are sending hellos out of our gig 0/1 interface. We are not receiving any hellos from our gig 0/1 interface. So down here, we sent another hello out of our gig 0/1 interface. That is in this direction. Remember I said earlier, we're not expecting any OSPF neighbors here. I'm not going to be an OSPF neighbor with this switch. I don't need to. So we can prevent that by using the OSPF passive interface feature. Let's go ahead and do that. Now, there's two ways to do this. Let me show you the first one. So I'm going to go to config T. Under the OSPF process, so router OSPF 1, I can say passive interface gig 0/1. Now, as soon as I configure that, Guess what router 2 is not going to do anymore? Router 2 is no longer going to send OSPF hello messages out of interface gig 0/1. We stopped it. But the network 192.168.2.0 will still be advertised and known throughout the OSPF domain. Let's verify that really quick on router 1 and see, after configuring passive interface, does it still know about the 192.168.2.0 network? Show IP route. Perfect. I know about this route from OSPF for this network here, 192.168.2.0/24. Let's go back on router 2 and let's enable those debugs again and see if anything changed. So to do that, I'm going to say debug IP OSPF hello, and let's give it a few seconds for some messages to pop up. All right, I think that's enough. I'm going to go ahead and turn my debugs off by saying you all or undebug all. If we look at the details of these debug messages, we can see here that, look at this, we sent a hello, we received a hello, we sent a hello, we received a hello, we sent a hello, all from gig 0/0. That's in this direction here. Now, let me ask you, what do we not see? We don't see any hellos being sent or received on gig 0/1. So the hellos that were going this way earlier are no longer doing that. Pretty cool, right? If I wanted to verify that OSPF interfaces were passive without looking at the configuration, I can do that. One way is by saying show IP protocols. If I bring my window up here, hit enter a few times, show IP protocols is going to give you really good information about all the protocols that you're running. Now, right now, I'm just running OSPF. I can see what interfaces are enabled for OSPF, but right here, here's the key piece of information. Look at this right here. Passive interface. This right here is telling me what interfaces are configured as passive for OSPF. Right away, I can see gig 0/1 is a passive interface. This is a really good and quick way to identify what interfaces are passive without looking at the configuration. Sometimes looking at the configuration might take too much time. It takes too long. The configuration's huge. Or you might not be allowed to look at the configuration. You might be in a CCIE lab and they might not let you look at the configuration. Another way that we can verify whether or not an interface is passive in OSPF is by saying show IP OSPF interface and then the particular interface. So if I put gig 0/1 and hit enter, I can see right away, right here, that this interface, gig 0/1, is configured as passive. Look, no hellos because we are passive. So it's showing us from this show command that gig 0/1 is passive and not sending hellos. Again, that's another good way to verify what interfaces are configured as passive. Another thing I want to show you is, let me go to config t router OSPF1, and I'm going to remove that passive interface configuration that I just added. Now, in this example, I forced gig 0/1 to be passive by adding this command. Imagine if this router had hundreds of interfaces. Do I really want to type passive interface for 100 different interfaces? No, that's going to take too long. That's annoying. So if I had 100 interfaces or sub-interfaces that needed to be passive, and the only interface that I needed hellos to be allowed to be sent out of is gig 0/0, there's a way I can do that. Right now, I reverted this configuration, so we're back to normal. I'm going to say passive interface default. What passive interface default is going to do is it's going to make all of the OSPF interfaces passive. That means that gig 0/1 and gig 0/0 are not sending hello messages, which is exactly why the OSPF adjacency between router 1 and router 2 here went down. And we can see that here in this syslog message. For OSPF process 1, our neighbor 192.168.1.1 on gig 00 went from full to down. Now we can fix this very easily by adding an additional command saying no passive interface and then the interface that you want to allow hellos to be sent out of, gig 0/0. And after a few seconds, we should see the adjacency come back up. Perfect, and it did. Router 2's OSPF process for neighbor 192.168.1.1 on gig 0/0, we are loading, and then we went to full. So this adjacency between router 1 and router 2 is back up. That's good. But we are not sending out hellos out of gig 0/1. So this was a really simple topology showing this, but imagine if router 2 had a whole bunch of interfaces here and we just made them all passive in one shot by saying passive interface default. Then we allowed gig 00 here to send hellos by saying no passive interface gig 0/0. Pretty cool, right? So that's a simple way to make all of the interfaces passive in one shot, then go back to the configuration and allow the specific interface to send hellos. So let me clear the screen here and just show you what the final configuration looks like. So right here, we defined our global OSPF process of 1. We said passive interface default, which made all of our interfaces passive and broke the connection or brought down the neighborship between router 1 and router 2. We identified what interface should be sending hellos out of, and we removed the passive interface status from it by saying no passive interface gig 0/0. That's all there is to it. That's going to be it for passive interface. Pretty cool, right? I hope this tutorial made the topic clear for you. If it did, smash that like button and subscribe to the channel if you haven't already, because more awesome networking content is on the way. I do have a Facebook group where I post a lot of content too, so check the description below for the link to that so you can be a part of that as well. And that's going to be it for now. Thanks everyone. Have a great day and lab on.